you can just do the tutorial. Along with all the files. Here, let me go through it here. Let me see. Ansys tutorials. Here is the workshop. Yeah, this takes you, right, model of post-processing and all of that, right? Let me see. And there are workshop input files. So I'll send you the workshop and the corresponding input files, right? The TA can put this. Oh, you don't have your the blackboard yet? Okay. So he's on his. I'll email it to you. Let me see how big this thing is. I'll email you the smallest. Yeah, this is not bad, right? This is just 1.6 megabytes, right? It's not bad. All right. So I'll send you a tutorial. You already got the. Yeah, this is what I just sent you, and the workshops. Okay. So, yeah, you'll get a tutorial, step-by-step tutorial. Right? Okay. So let's do this now. So we now double-click steady-state terminal. Okay. So now, the first thing we said is we're going to create material property. Create. So we'll go to engineering data. Double-click engineering data. You see where it says here, click, and again, you don't need to take much notes. There's a tutorial. You click here and add a new material property. So I'm going to call it block 1. Hit enter. All right? If I want to edit it, you notice I can't edit it now, right? I click here and I select that and I put a value. Now, the only thing that matters, I picked steady state. You notice it was smart enough to filter out. It didn't give me rho, didn't give me CP, didn't give me all the coefficient of thermal expansion, Young's modulus, right? Because it's not needed. It's only steady state heat production. So just give me the. So I select that. You notice when I select it, it means I want to edit it. So I'll select that. Let us say I call that 50 watts per meter degree K. Oh, I got to double click isotropic thermal conductivity. All right, it's not orthotropic, okay? So it comes up here. So now you say, you notice if I click here, it won't allow me to change it. I have to select it here to edit it. Right? This is editing. So let's just give it a value, 100 watts per meter degree K. All right? Now I'm going to click here and add block 2. And same thing. And call it, say, 50. And then I create, click here, block 3, and I select, right, say 10. Okay? So just remember now, this is what, 100, because I have 150 and 10. All right, so now you notice if I got it in this form, right, I have to take this off so it's not, now I take this out, so it's already, now it's good to go, right? So it's defined. In other words, if I have this, it's an edit form. It's got a strike on it. I can change the properties. When I'm done with that, I can just select this, check this here, so everything is clear. Now I'm going to update the project. So I have 3 material properties. Okay, that's it. Right, so I have defined 3 material properties. Now I return to my project, and I go to geometry. Now there's many ways, right? You guys know CAD. You can create a surface. Now, I always say, do it in the path, have a plan. For example, something like that, the first thing you ask yourself is there a primitive macro to create this? If there's a primitive macro there, right, in solid modeling, right? If you have cylinder, blocks, and so on, there's primitives, right? So use the primitives. Otherwise, you can always create a surface. So I'm going to use millimeters for units. Okay. So under create, you can go to primitives and select a box. All right. So now it creates this box. Now let me tell you what this is, so you can be very familiar with it. This is the corner location, and this is dx, dy, dz. This is the diagonals, right? So this is the corner, the first point. And so if you want to, we can parameterize everything, right? So I can call this, for example, x1s. All right, x1s. It picks up whatever value it is right there, right? And I can pick up here, oops, y1s. And I can pick up here z1s. All right? And same thing here, except x1f, actually it's really dx1, right? It's not the diagonal point, it's the delta x, all right? It's what this is. It's delta x, dy1, and this is dz1, all right? Now, it doesn't matter for the first object. It says here, add material. That means, you know, typically it's good to create a frozen. When you create the second material, you absolutely have to make sure you say frozen. Otherwise, if I have a box here, if I have created this, and then I come back here and create something like this, then it will look like this. If I say add material, it means it just adds material. But this won't be a distinct object, which means I can't put the distinct material property. So I'll have elements like this, for example, right? I can have elements like this. So it's going to only be one material property. Very important. Really important you do that. I'll show you. I won't actually put it where it's not. Okay, so we have defined this, totally parameterized, right? So we say generate. So there it is. Now, if you now, let's call this, rename this to block 1. Okay? Now, the interesting thing here now is I can go up here, right? And to where the parameters are. And you notice here, dx1, dy1, let me just change dx1 to 100 and dz1 to 100 and say refresh project. Okay? And then I return that. So now if I go back here, so it just updated it. You see that? It's being updated now. If I look at the box, the dimensions of the box, you notice it says 100, 100, right? It's because we have parameterized, right? So now let's create another one. Same thing. Box. And Remember, you want to have it frozen, otherwise, so let us say that add frozen. I want to simplify it so it's one-dimensional problem so we can check it analytically, and then later on we'll totally change this up. So let us say the x location where it starts, so we will call this what do we got? X2S, right? Okay. And the y location must be what? I want to put it right on top, so it's going to be dy1, right? Yes, I've already defined dy1. And this here, I just want to make sure it's on top of it. This here I can define, so let me define that as what is that? CS1? How did I, let me see what I did. How did we define it? It was Y1S, Z1S, so we define X2S, call it Z2S. So this is going to be dx2, right? And this is dy2. And this is dz2. Now, I haven't defined this. This is going to be why am I forgetting? Just to be consistent, Z1S, right? So it's going to be Z2S, right? Yes? So this is going to be Z2S. Z2S. Okay? So it's fully parameterized. So we can just say it's frozen. Suppose that I didn't have it frozen, then we'll just be, let me just get rid of this and just say add material, and say generate. There won't be any interface here. See that? Right there, there will not be, it won't, this is all one material. So this is why you need to put here. So you come up here, edit this, and say add frozen and generate. All right? We'll fix where it is and all of that later. So now let's do one more. So I'm going to call this block 2. And then just one more. So you get the gist of it now, right? So we're this one here, let me just call it, so this is going to be X3S, right? Is that our form? X3S. And this is Y3S. I know it doesn't look good, but that will fix it. Y3S. No, this is 3. This is the third one. I know, but it's Y2 plus. We'll fix it. So you're right. It's not going to be on top right now, right? So supposing you forgot it, you just put a variable there. So Y3S. And this is going to be Z3S. All right? And this is going to be DX3, right? DY3 and DZ3, and we're going to say add material, add frozen, so generate. So I don't know where it's going to be, someplace, right? So now you go up here, you go to where, this is the beauty of parameterizing, right? Watch this now. This is really something we have to. So now, which one do we want to fix? The starting point in the y direction, right? So we want where's y2s? I mean, y3s, right? Y3s is a problem, right? So I'll go to y3s, I click it, and then come to expression here. Y3s should really be equal to dy1 plus dy2, right? So dy1 is what? P5. P5 plus, what is dy2? P9, right? Yes? So P9. Okay? So I'm going to update the project here. So if I go to the geometry now, look what happened. It's up there, right? And now I can change the dx. So let's change this now to what I will do is to make it one-dimensional. We know it's L1 over K plus L2 is something, right? If it's all the same dimension. So let's make it all the same dimension for right now. So it can be nice and one-dimensional. So I would say that that dx2 is 100, right? This is 100. But, oh, not dz2. I'm saying yes, because we start from 0, right? Correct me here now. The starting point, the S is, oops, let me just do this. So, let's look at the first one, x1x, this looks good, and 100, right? And then the x2s is 0. Where's y2s? Y2s is, you guys see y2s? What happened?
Huh? You didn't define, you used y2.
Oh, I didn't.
dy1.
So we really should, this should have been, if I look at y2s, y2s is right here, right? It's defined by this block. Oh, it's trying to update. Okay, let's just update this thing first. Okay, so now if I look at y2s, edit. Oh, it's not done yet. Select the point, generate. Okay. So,
I think the details view window on the bottom there, maybe?
Yeah, you pushed it all the way down. You need to drag it back
That
up.
oh,
yeah.
yes.
Right
There it was. Yep. Right there.
Okay, yes. So, thanks, guys. So here it is, right? So, right here, I want to make this thing here y2s, right? So I'll just click it and call this y2s. Right? I know I just set it equal to something. So now let's go up there. The parameters. Here's y2s, right? y2s should be equal to what? y2s should be equal to dy1, yes?
P5.
So where's dy1? Is P5, right? P5. Yes? And so now we're good. So let's take care of 2. So we got everything is 2. We got dx2 is 100. dy2 is 30. dz2 is 100. dz1, where is z2s is 0, good. And y2s is where?
At the very bottom, P18.
Yes, y2s is that's correct. What about z2s? 0, right? And then we want the deltas. dx2 is 100, dy2 is this, dz2 is this. Okay, So now let's move to the third. The third one is X3S 0, that's okay, right? Z3S is 0. Y3S, we should define that as, yes, we defined it correctly, right? That has to be defined. And then DX3, because I want this thing to be one-dimensional, is 100. All right? And DZ3 is 100. All right? So, I can tell you, once you start parameterizing, you really fall in love with it. Because, so here it is, right? It's all the same. So if we now check it, if you check it, you can see that 100 by 100 by 30, right? It starts at 30, 100 by 100 by 30, and what I want to do though is at least change the heights a little bit. The heights I can play around with because it's still one-dimensional. So let's change dy2 to 50 and dy3 to say 60. So we're now set to, it's just going to be a little taller, right? Right? So now if I check this, box 1, 100, 30, 30, box 2, 50, right? Box 3, 60. Okay. Right? We're good. Now, let me show you where you really, so you're now done with geometry, right? Okay? You'll parameterize it, you can do wonders with it later. So now let's get out of here. So you say File, Close, Design Model. All right? Now you go to Model. And for the first, so under Model, if you really want to be good at this, you've got to know how to, I'll just tease you a little bit and then do it another way, but we need to create name selections, right? So we say insert name selection. And the key ones here is really this top one here. So this is a surface. So I'll say geometry selection, surface, make sure the surface is selected, and apply. So this is going to be, I will rename this into H coefficient. This is just a surface, right? I'm going to apply. And then if you click this, notice if you click it, a little red thing comes on, which means I can rotate it. So now I'm at the bottom. Here's I'm going to apply a flux. So let me tell you a nice trick here. Just duplicate this. You know, just to cheat, just duplicate this and just rename it. Say, call it flux. Of course, if you select this here, it's going to point down, right? Because it's just a copy. Now you just edit the face here. Select this face and apply, right? This looks trivial, but let me show you where it comes in handy. Supposing now I want to do something a little tricky. I won't do it now. But supposing I want to start using name selection. So I'm going to say here, flux, duplicate. Now for geometry purposes, I want to do something. So I'm going to say, oops. Let me select his bodies, right? I'm going to select the body here. And the bottom one, right? You notice I selected it. Oops. I selected that body, right? So we're going to call this bottom body. Or block one. Now, again, duplicate this. Just duplicate this. call it even body 2. That's good. So except just select this guy, apply. So that's how you cheat and move very quickly. Duplicate this and select this body, you apply. So you now got all your geometries, right? It's select. Now, so what was the big thing I was talking about? So I take this flux. Now this is surface and duplicate. Now let's see what we can do. Geometry selection. I select here and say worksheet. I'm going to go to worksheet. I'm going to say let us say that I want to identify all of the vertical edges in body 1 because I want to give them a certain measure, right? So all of the vertical edges, I want to give them, say, 5 cells. I just want to show you how you identify it. So you say action, add row, and then it's body, that's fine. It's going to be name selection, equal, and then you pick the body that you pick, block 1 body. Now you say, right mouse click, you add row. You say convert this thing, only body 1 to edges. Convert it all to edges. Now if you say generate, how many edges would you expect? The bottom block. How many edges will a block have? Huh? Go ahead. How many edges will a block cuboid have? Huh? Edges. How many edges will it have? You're what?
12.
8. You're almost there.
12.
12.
12.
Yes. So if I click here, it should show me, if I say generate, it should say 12, right? So if I look at the geometry here, you see, it picked up. Now I can hide this thing, by the way. I can click here and say, hide this, guys. Hide this too, so you can see. Hide this body. So you can see that it picked up, right? It picked up all of the edges. Now I want to be able to say, I only want the vertical edges, right? So this is where investing some time in name selections really, really makes you feel good later on. You can do wonders. So now you can come up here and say, I want to filter. So here's what you do. Action, add row, and they say remove, filter, and then I want you to remove. Now let's just have a discussion. This is Y face, right? I want to remove all of Y maximum. All of edges on the maximum Y face, right? Let's try to do that. So edge by location Y. Location is going to be the very largest Y. And it's some trick now. Later on, you'll see that. If, depending, like right now, I'm going to have a problem actually. And so there's a way to getting around it. The reason I'm going to have a problem is it's not going to select anything. You would expect it to. So it's going to say 0, right? Generate. Nothing. It didn't filter anything. I don't mean to say filter, remove, right? Generate. It's still got 12. Because the reason is Y largest. This is now Y largest. This is not the Y large. The domain Y largest is the very top, right? The largest Y in the domain, right? So a trick you can do is this. You can go up here. You can say create a coordinate system. You can just create a coordinate system, and you can say let this be, pick a point. Pick this point here. Apply. Now you got the coordinate system. Let's call it bottom coordinate system. Now, this coordinate system then this is 0 right here, right? This is your 0 point right here. Y is equal to 0 here, unequivocally. So now if I go up here to where I was doing all of this stuff, and I remove, now I change the the coordinate system here, if I can just grab it, from global to now it says I've created a coordinate system, right? And I'm going to say equal. I actually know what the value is. It's equal to 0. Location y, yes. And this is going to be equal to 0. All right? Let's see if it's going to remove this. Now you should expect to see 8, right? Generate 8, right? So you can see here it's gone.
Your coordinate system didn't change.
Wait a second. You should have taken.
It's your coordinate system, and you never changed it from global.
Oh. All right. So now if I say remove, if I click here, right, generate, I got 12, right? Now if I select this, so you can see I got everything, right? Now if I now include this and say remove, it's got 8. And if you go here, the top are gone, right? So now by analogy, so you can quickly say, action, add row, so you got it now, right? So you can say remove, right? Edges. Now it's going to be location Y equal to 0 on the low. We know daggone well this is the global coordinate Y is 0 here at the bottom, right? So as you need it, you create it. So you go in here and say remove, generate. There's 4, right? So it's 4 coordinates, right? 4 edges. And then you can go under sizing and put all kinds of elements and that kind of stuff. So I want to at least finish this thing, so I won't use that.
What's your motivation for removing edges?
Because what you're trying to do is this. Let us say you want to use sweep method, right? And you really want to control the number of elements in the Y direction, X direction, and the Z direction. You can do this, and now I have this group. I'm going to call this bottom. I'm going to rename this. Good question. I'm going to call it bottom Y direction, right? All right. Just keep that in mind. I'll use that in a minute, right? So I now got this thing called bottom Y direction. So what I can now do is, when I create a sweep, if it's sweepable, you can go up here to meshing, check to see if this is show of the bodies are sweepable, and it's certainly sweepable. You see that? Sweepable means it will create a 2-dimensional mesh and then sweep it. Some things may not be able to do. 4, right? And I'm going to change the element size to number of divisions. And let's just say I want 10. 10 there. All right? Now I'll come back here and say generate mesh. All right? So now you can see, show all bodies, that here you have, it's always good to click here so you can see a little clearer. But now you have 10, all right? Okay, this is just, I'm not kidding you when I say it's a tease, but because it is really how you can make this thing dance. You can do so many things with it when you do this kind of stuff, right? Name selection. I mean, there are tons of things you can do. You can control, especially when you have a complex geometry. If you don't use name selections, you're absolutely not using Ansys the way you should. So you should absolutely do that. So now we got this name selection. Let's use it. Let's now go to boundary conditions. I got what I want. I'm only going to do flux here. So if you notice flux, if I rotate it, the flux is in the bottom surface, right? And the heat transfer coefficient is, I got what I need, so I'll get out of here. Close mechanical. now I'm going to go to setup. And very simple problem, right? So now you got to know physics, right? Physics says the boundary value. Everything is going to be adiabatic except the top and bottom. So let's just put here, insert convection boundary condition at the top. So geometry selection, I've done my dirty job. I've taken time to create. I don't need to pick a surface because you notice this is fairly simple, but so it picks the top surface, H coefficient, right? And the film coefficient, let us say 1,000. I have an analytical solution. The units I can change. The units of temperature, let me say I use degrees Kelvin, 300. This is the ambient temperature, right? So now I put the flux. Insert flux or heat flow. Heat flow, that way I can control heat flow where in the name selection, even though I call it flux, it's really heat flow. So I'll put 90 watts because I know I have analytic solution. You can put anything you want, right? So what happens, we say this is steady state heat conduction is elliptic or boundary value, right? No transient in here. So what do you need to do? You just, what happens to the rest? I should have, this is, if I show the mesh here, I got all these elements here. I have to have at every node, at every point here, I need something. Either boundary condition of the first kind, second kind, or third kind. So what boundary condition is of this surface, guys? Can someone tell me? Because I only put boundary condition on the top and the bottom. What about the sides?
Insulated.
If you don't do anything, it's adiabatic. So you have to know the physics. In other words, you're not violating basic principles. You are applying a boundary condition, just so happens to be adiabatic. So you're good to go, really. You got the boundary value, you got the boundary condition, so you can now say, oh, you didn't put the material properties, right? Block 1. And you notice that it is the default is structural still. So if you click here, it's going to show you the stuff that's, so here's block 1. And I'm going to come up here. Block 2. We'll select this guy here. Forgot to call this, but it doesn't matter. And I'm going to call this block 3. All right? So now let's just solve. And I really didn't need all those elements there. But, okay, it's done. So now I can just add temperature, all the bodies, and show. So here's the temperature. This is what you would expect, right? Highs and bottom. But now, this is relatively simple. Now, if you get in 374, so I got a cheat, something I can cheat with, because it's such a simple problem. I got a simple spreadsheet. So now we can just plug in. This is correct. This is just in SI units 100. But this is dy1, dy2, dy3. Can you guys remember what that is? So if we go up here to parameters, dy1 is what? 30, 50, and 60, right? So 30, 50, and 60 to the minus 3. This is H, And reference temperature is good. This is the power. Now, what else? Oh, the thermal conductivities. You guys remember that? So we can go back to engineering data. 100, 50, and 10. 100, 50, and 10. All right? So it should be 374 degrees Kelvin. Yeah, there it is, right? So now, just the thing that you're going to appreciate right now is this. So you're going to go up here and say, you know what? I'm just going to change things around. Let me change some parameter. Let us say I want to change any one. Right now, if you look at it, just so you can see the geometry. The bottom one, let's make it very thin, right? So dy is 3. Or what do you want to change? It doesn't matter. Change anything you want. So dy 3 is, where's dy 3? Right. So let's make this 10. All right? Now you say update all design points or update the project. Then it starts cranking away. You know, the mesh, the whole 9 yards, right? So you notice, you can see that, just change that, and now it's getting ready to solve. Now the only thing we changed, right? So it's done, not quite. Now if I look at the temperature, right, drop that you expect. Now, what was it, dy, what did we change it to? Dy, this was to 10 millimeters, 10 e to the minus 3, right? So there it is, right, 329. Yeah, so now, this is where you really actually makes it very, very interesting. So the middle one, right now, dx2 is at x2s starts at 0, right? Let us say you start x2s at 20, right? So it's not going to be in the corner, all right? And then dx2 is going to be, say, 60. Right? So it's going to be 20 on each side, right? And then let's do the same thing to dz2. Z2s is 20. And dz2 is 60. Right? No analytical for this, but so if we now update the project, spreadsheet won't work anymore because this is now one-dimensional, right? Because you got spreading resistance. Distortion. You see how it's changing the geometry, right? So by parameterizing, you can do a lot of interesting things. I'm going to show you one more thing, then we'll. So all of this, you understand this, you really know how to solve electronic cooling problems, except it's not that easy. You still got to use ice bag and fluid and stuff for more complex. But conduction problems, which is a big part of it, this will get the job done. Okay, is it done? So there it is. Right? finally, one thing you can do is you go to geometry and change something, not 4 minutes, but maybe we'll. So let us say that you want to actually form the power little. So now I'm going to say create new plane. I want to create a plane from on a face. Apply that. Generate. And I want to sketch on it. So I'll sketch rectangle. Where is it? Right here. So I'll just keep it simple, right? Something like that. And I won't even dimension it. I'm just going to say generate. All right? And so now we have that. And now I'm going to, I have that sketch. I'm going to create surface from sketches. All right? And you notice here, you have 3 bodies. Watch now. It's going to create a surface body, right? It's going to create a surface body. Now that you have the surface body, you can partition. You can say create Boolean and you can do the imprint command. It basically means you want to, the tool body is the surface body. And the target body is that top one. What you're trying to do now is generate. Now look at the mesh now. I mean, look at the area now, but at the top. If I look at the area, I have this area, right? And I have this area, right? Now you go back here to here where you had defined name selections, where, oops, I had to do an update. Yeah, it has to be updated, right? Geometry changes a little bit. We're about 2 minutes away. And, so, where is it at? Do you see that surface there? So now you go where it says flux. Flux with this surface, you change it. You change it to this. Apply. Now you're going to see quite a bit of constriction resistance, right? So now I'm just going to use the default mesh, except I'm going to change this edge sizing mesh. Instead of 10, I'm just going to make it 4. So I don't have to wait forever. And so mesh, and you clear this, and just do that again. Right? I mean, I would not do it like, I'll show you a little bit about meshing. So you can see the bottom one now. Now, if you look at, frankly, you know, what you're supposed to do with this flux surface here, this is really where you really need to create, see how we did bottom Y direction? This is where you cheat. You say duplicate. And you pick that same body, everything looks good, except you, instead of delete this guy here, and instead of remove, to say filter, and y is equal to 0. So what you're doing here is 8 edges, right? If you look at this, you've created all of the 8 edges, right? Now you want to remove the big ones, right? So you can say, you can trick it now. You can say add, row, remove, edges. I mean, there's all kinds of size, largest, all the largest ones, generate. So you can see 4 edges, right? It picked up this 4 edges, right? Now you can be a little bit more creative with this, duplicate this edge sizing. I duplicate it just the same way I type. I type with 2 fingers, so I don't like to. So you take this and you change this to, what is it called? Bottom S. And now you really put a lot on it, say, yeah, 4 by 4. So now you come up here and say, you see how coarse this mesh was here? Oh, you want to make it hard. There's a couple of more things that yeah, you gotta make this. You want to force this thing to make sure it's. Now you say generate. Now look at this mesh here. So it's a little bit more denser. It should give me.
No change.
Anyway, let me just solve it then and finish the class for today. So we'll just solve this. So you can see the spreading resistance, right? So it's going to be very hot here. Oh, it's done, right? So you can see that, right? Very hot at that point. Okay. So I'll send you some tutorials. It is really powerful, but you want to be able to solve thermal and mechanical using this.